This is a NEET 2016 question in wave optics basing on Young's double slit experiment. Pretty interesting. We will cover a lot of concepts while we are solving this problem, so that even it works like a revision for the Young's double slit experiment. Let's have a look at the question. The intensity at the maximum of the Young's double slit experiment is I naught. So first I will explain how does the Young's double slit experiment works, and then I will come to the intensity point. So there will be a single source from which the waves comes, which is passed through double slit. That's why it is called Young's double slit experiment. Thus each of the slit acts like a source. The distance between the two slits is considered as small d. We will capture the resultant on a screen where there will be formation of bright and dark spots. This is the screen. Distance between the slits and the screen is called as capital D generally. Now what happens is the waves will form bright or dark spots. What happens, how does the wave goes from here, from the slits? Let us try to understand, right? Let me just extend the slit diagram. So from here wave will go and strikes the screen somewhere. From the second slit also wave will go and strikes the screen somewhere. So it's very clear that they together on the screen at a point y form a bright spot or a dark spot. It's very clear that the upper wave is shorter and the lower wave is longer. Then these two together have certain difference in their path. For that, from the upper you have to draw a perpendicular line, and this line what I am drawing right now is called the path difference between them. So if you consider a line in between them for an average, if this makes an angle theta, then here also there will be the same angle. Then we can write in this triangle, what I am drawing here in the triangle, sin theta could be written like delta x by d. And then in the another larger triangle, that is this triangle I am talking about, in that larger triangle we can write tan theta as, from here to here we call the distance as y by this distance as d. As now what we can say is, as theta is small, sin theta is close to tan theta, that is what we can say from that, delta x by d, that's the path difference, equal to y by capital D. So y equal to capital D by d of delta x, where delta x is the path difference. Now what we can say is at this point, at point y, intensity of two identical coherent sources I resultant can be written like, in general, 4I naught cos square phi by 2, where phi is the phase difference. That what are we talking. But in the problem he said something like I naught, the intensity maximum is. So here in our problem I have to call it as I naught cos square phi by 2, but be careful where I naught is maximum resultant intensity of the interference pattern. That's what is given for you. It is further given in the problem. That let us see what is further given in the problem. Distance between the two slits, this small d, is 5 lambda. So let us take that what is given for us further. Distance d equal to 5 lambda, where lambda is the wavelength of the light used. What will be the intensity in front of one of the slits on the screen placed at a distance of capital D equal to 10 times of small d? But this small d as per the above data is given as 5 lambda. So, in the other sense he is saying you can say it is 10 d or 50 lambda, both of them can be used. One more important word is intensity in front of one of the slits. So, where he is asking the intensity? He is asking intensity, this is one slit. One in front of one of the slits means at this point where is the intensity is. So, I shall know what is this y is or this y dash is, as it is very clear that distance from here to here is distance between the slits D, and this distance is obviously half of that distance. So, the point where he want to find out is d by 2. This y dash is d by 2. He is asking at a point y who is opposite to one of the slit, means your y equal to d by 2. That is what is being given for us in the problem, right. So, if y equal to d by 2, what is this delta x is? We can find out what is the value of that delta x is from this relation. From this relation, as it is given that y equal to capital D by delta x. Delta x can be written like y small d by capital D. This y is at a point opposite to one of the slits, so that is d by 2, right. And then d, capital D can be written in terms of the small d as given in the problem as 10 times of small d. So, 1 d can be cancelled, so that is d by 20, capital D equal to small d divided by 20. Of course, small d can be further written like as per the given data 5 lambda by 20, that is lambda by 4. So, the path difference on the point where you have to find the intensity is lambda by 4. Once if you know the path difference, you can find the relation between path difference and phase difference as delta phi equal to 2 pi by lambda into delta x. That is 2 pi by lambda into path difference is lambda by 4 on the screen. So, the path difference between the phase difference between the points at that point where the two waves reach is pi by 2. Once if you know the phase difference, I can find out resultant intensity, but I do not write 4 I naught because in the problem intensity maximum is given as I naught. I will write it as that I naught itself. So, in this relation, let us find out at opposite to one of slits, resultant intensity is I dash is I maximum, that is given as I naught cos square phi by 2. So, I naught cos square phi we have found it as pi by 2, and there is another 2 that will be pi by 4. So, I naught cos square pi by 4. You know, cos pi by 4 means cos 45. Cos 45 is 1 by root 2, square is there. So, that is I naught by 2. So, the intensity at that point is I naught by 2. That is how we have to solve this problem. So, this looks like a little big problem just because I have taken the time in explaining all the aspects of the Young's double slit experiment. Otherwise, it is a simple problem. I have just extended it to a larger level so that while you are learning this question, you will be learning a lot about Young's double slit experiment also. That is it. You can go through this question once again if required and make a comment if there is anything that you need to clarify, you need to get clarified, right? Thank you.